Hello and welcome to page 1 of the Unit 1 notes. The first part of this packet, we are going to be looking at just kind of some fundamentals of chemistry. So the first part on here is some of the elements, the really common elements, and their names, and then the chemical symbols. So you'll use your periodic table to find these. And it's really important to notice that capital letters are used for the first letter of any symbol on the periodic table. So just for example, lithium is abbreviated as L, which we would do as capital, and then lowercase I. So if there are two letters for a symbol, always the first one is capitalized, and then the second letter, if there is one, is lowercase. It's really important to know the really common elements and their symbols so that we can talk about chemistry the way that chemists do by writing out formulas. So that's the first part on here. Moving down the page, just kind of some general science knowledge. So scientific basics. There are two main categories of experimental data. So when we collect data in an experiment, it might be either qualitative or quantitative. Qualitative should make you think of qualities. So if you describe what type of qualities your friend has, you might say that they're nice or friendly, or they are athletic or into music or into drama. And so those would all be qualitative. And so for qualities, we're describing things like color. My paper is white. We might describe the shape. My pen is cylindrical. We might describe the phase of matter. Water is a liquid. So we are describing something that is quality about that object for qualitative. So this is really describing or descriptions of those qualities. Quantitative sounds like quantities. And so for quantities, this means numbers. So instead of just saying my paper is, white and rectangular, I might need to get a ruler and measure the length of the side. So this piece of paper is 8.5 by 11 inches. So we might measure the length of this paper is 11 inches, for example. You might measure a weight. So maybe a baby is born and it weighs 9 pounds. So we can describe something with numbers as being quantitative or a measurement. We could keep going. We use grams a lot to measure things on scales in our class, and we would measure using centimeters. We could count. So you could say 5 pieces of paper. So these are just some common examples of quantitative descriptions. Okay. We're going to practice real fast with a quick demo. So we're going to make some observations before, during, and after. That's what these 3 boxes are for. So I'm going to go ahead and get started here. So we're going to start with this. So if we were going to make some observations, you'd pause here and make some observations on your own. I have a piece of paper over here with some of the observations that students last year made. So somebody last year described the color as cream colored. Somebody else said they thought the size was little. Right? Somebody else said if we had a ruler, we could measure the height. Somebody said the shape was a cylinder. Okay, so all of those are qualitative, describing the qualities. And then I asked, well, what about something that's quantitative? And somebody said there was one, right? So one object. Okay, so those are examples of qualitative and quantitative descriptions. For during, ooh, this thing's making a lot of sound. All right, so during, we would pause here, make some observations. All So for this section, some of the observations that students last year said were it was lit up. Some people said we still see a cream color and a burned color at the top. One person said the fire was red. I don't know if it was red this time. I wasn't looking. I think it was kind of a yellow maybe, so we'll throw that on here. That was my observation. And somebody else had said there was smoke. Right. Those are all qualitative. They're all describing the qualities. If we wanted something that was quantitative, we might have needed a stopwatch to measure how long the flame was going. Or we could still, look for a scale and try to take a weight or get a ruler and take a measurement. So we didn't do those things, but those would be examples of quantitative measurements that we could have taken. Okay. For our last box for after, we're going to go ahead and take a look at this one more time. Okay. So you'll pause here and write down some observations. Some of the observations from last year, this was more a question, but maybe it was tasty. Somebody else said it was eaten. So that's kind of something that's a little bit more of an observation versus, is it tasty? That's more of a question. And then we had some people speculating that it must have been something that was edible. And there were a lot of guesses as to what edible material that could have been, which again, not necessarily something you can observe that it was edible, because maybe it's not edible and I just poisoned myself. So the whole point of this, when we're looking at this demo, is we want to think about what you're seeing and really paying attention to detail. So when we're looking at this, there's a difference between an observation and an interpretation. An observation should be something that's based on fact. It should be something that you're just describing totally objectively, I guess, something that other people would probably agree with you on. So cream colored, maybe you'd argue a little bit about what color is cream, is it white or off-white or whatever. But a lot of these things, people aren't really going to argue if you say there was one object, or, the size of little is a little bit subjective. But, we could make a measurement of it. The shape of a cylinder, those are things that are going to be more factual and fact-based. An interpretation is what your brain does with this info. Your brain interprets what you see, and it takes in all those facts, and then your brain draws conclusions. And this is a really important skill in life, that you can see something and then you can draw conclusions from that. You do this all the time when you decide if it's safe to cross the street. You look and you listen for cars. And so if your brain says, oh, you don't see a car, you don't hear a car, then you assume it's safe and you can cross the road. But it's important to know in science that everybody's process of getting from an observation to an interpretation is a little bit different. And you want to be mindful of that process and be aware of when you're making interpretations versus when you are making observations. This is something that's really important in science. In science, we are always using models, and models are our brain's way of interpreting the world around us. And we might then draw a picture of what we think is happening, or we might explain a process in words or write an equation. You guys have seen a lot of models over your life. Some common examples would be cells. We draw pictures to show what we think is happening inside of cells and all the different pieces of cells. We draw pictures of DNA to represent what we think they look like. We draw pictures of solids, liquids, and gases, with the particles spread out differently. This picture is too small. There's lots of cycles. I don't know which one I put in here, but like the water cycle, the carbon cycle, atoms. All of these are examples of scientific models, times where we've used drawings, graphs, equations, words, etc. to communicate what we think is happening inside of something that's too small for us to really see it with just our naked eyes. And this is a really important scientific practice that we use all the time. And this is something that we're going to be talking about more throughout our class. Some of the other science and engineering principles that scientists use on a regular basis: asking questions and defining problems. This is the whole point of doing an experiment, right? You have a question, you're trying to figure something out. We conduct investigations in order to try to answer our questions. We collect data in experiments, we have to analyze it. We use math. Constructing explanations. So this is that interpretation process again. We argue from evidence. Does the evidence support what your interpretation is? And we communicate information with other students in the class, students with teachers, teachers with other teachers, and scientists with other scientists in the scientific community. That's why scientists are publishing findings and they go to conferences so that they can communicate their findings. These are some of our really important scientific processes, and we will be continuing on with these different ideas throughout the course.